Now we've seen that solar voltaic and onshore wind are the cheapest forms of energy generation at the moment. But they have a problem. The sun doesn't always shine and the wind doesn't always blow. And as the opponents of renewable energy will tell us, that is a problem. It's not enough to have electricity some of the time. For many applications, you want it all the time. You don't want to have your refrigerator not working for one day a week because your food will spoil, or your hospital can't operate because the lights are out. This is a big problem in some countries in Africa which have unreliable energy supplies. Energy has to be available 24 hours a day, 7 days a week, 365 days a year, and that is a problem for solar and wind energy. So what are we going to do about that? Well, let's look at some data for how much of a problem it actually is. Canberra, the Australian Capital Territory, has a target of 100% renewable electricity, a target which it has actually met. But that's 100% on average. It's not 100% all the time. Here are some data for, this is a week or two in April 2019, and the black line here is the power needed by Canberra, being demanded. It's got a daily cycle of more power during the day and less at night and so on. This is April, so it's not particularly hot or cold, but it does still vary from day to day, probably depending on the weather and weekends and so on. And the colour bar is showing the actual energy generated by the ACT's renewable sources. The different shades of green are different wind farms, some of which are located near Canberra and some of which are located much further away, but paid for by the Canberra government, the ACT government. And then you've got various shades of yellow and orange, which is solar photovoltaics, some of which is on people's roofs and some of which is in big utility scale places. And what you can see is there are times when the wind and solar generate much more electricity than Canberra needs, and there are times when it's less. So in the middle of the day here it was both pretty sunny and obviously quite windy where the solar farms are, where the wind turbines are. Over here there was a long period of very windy weather and a fair bit of sunshine as well. But down here it was the middle of the night, so there was no solar energy and the wind had completely eased off. You can look at a similar graph for South Australia, another location which generates at least some fraction of the time 100% of its energy from renewable sources. And what you can see here is yellow is solar, from roofs and utilities, mostly rooftops in the case of South Australia. Green is wind power. Then the various shades of orange now are gas. And purple is importing or exporting energy from the national grid, so they might import energy from Victoria or New South Wales. And what you can see is, once again, you've got the day. This day there was a lot of solar power. It was clearly a rather sunny day. Not so much wind power, but nonetheless it was producing more energy than it needed, so it was exporting some. Here's another sunny day. Down here, lots of sun but no wind, but still enough sun to export. Whereas here, it wasn't so sunny. There's a lot of wind, though, especially in the evening. But there are periods like before dawn here. The electricity demand is quite low, but there's no wind and no sun, so they had to use gas a lot or import a large amount of their power. And there was a whole night here with not much sunlight, not much wind, where they had to import a huge amount of power. So what are we going to do about this? It's okay if you're the ACT or South Australia and you can import or export power from nearby places like New South Wales or Victoria, which generate most of their power using coal. Well, this is what's known as firming. Don't ask me why, it's trying to make it firm, I suppose. But basically the idea is to try and take your variable energy and make it reliable enough that we can always have a firm guarantee that we will have electricity when we need it. Now, one step is to have a mix of solar and wind, not just purely one. Even though solar photovoltaic is probably cheaper than wind at the moment, you can see from here that actually the combination of the two smooths things out a lot. There are many times like this night here when there's no sun because it's night, but there's a lot of wind power. So combining the two is definitely better than either one by itself. There are periods like here where there's not much wind but a lot of sun. So keep both. Don't just go for one or the other, even if one is cheaper than the other. Geographic spread also helps. It's helpful if you don't have all your wind turbines in one place. An awful lot of the wind turbines in Australia are on the South Australian coast between the Victorian border and Adelaide, because it's a very windy place with power lines beside it. But that's dangerous. That just means there's one location. If there's no wind there, that can cut off a lot of the supply. So what you'd like to do is use the national grid to move the power around. Here is Australia's national energy market grid. Western Australia is not part of this, they have their own separate grid, but you can see the different transmission lines of various amounts of powers. Normally there's a network in each state, and then there are a few interconnectors to bring the power from one state to another. But they were originally set up as separate networks in different states. It's a long stringy grid. You can see it loops around from here up to here with radial distribution. It was originally designed to take power from a few, for example in New South Wales, a few power plants near the Hunter Valley where there's lots of coal, and export it to where it's needed. It wasn't really designed for electricity to go the other way around, because it could be the wind farms, many of which are down here. They need to get their power, say, to Sydney, and it's not designed for that so much. Also, there's a shortage, for example, of electricity cables just on the Great Dividing Range up here in Queensland. If there were more along there, and there are plans to build them, that would be a good place to put a lot of wind turbines, and it's going to be different wind up here from down there. The weather patterns in the monsoon north of Australia are quite different from the temperate south, and that would again help even things up. But the trouble is, it's difficult to build the transmission. It's expensive to build. In fact, in many countries, this is now one of the biggest things that governments are trying to chip into. It's also time-consuming to get permits to build, especially because transmission lines are long. If you're building a wind farm, you might be able to build it in just one farm or a second farm, so you only have to persuade 2 people to sell you the land. But a transmission line may go over hundreds of farms. What are the odds that one of those 100 farmers will refuse to sell? There's often local opposition. People once again think that it's an eyesore, or maybe they use planes to spray fertilizer over their fields. They don't want to have power lines in the way. Again, you have to make some sort of deal whereby it's worth the while of the local farmers to sell the land, and they get a good deal out of it, so it's a win-win for everybody. But often that's not been done, and there's a lot of local opposition to it. So that's the trouble. Transmission would be great because it would allow more wind turbines, more solar plants in more of the country, but you're going to have a lot of fights about it, and often it can take years to get planning approval. You have to get the agreement of everybody it goes through. In the United States, this is a particular problem because a power line might have to go through multiple states, each of which has its own rules about how you get permits, with different political people in charge of all of these things, and trying to get them all to agree, yes, we want to build this, we will build it, we'll purchase the land, can be hard. So what else can we do? One technique is just to overbuild or use demand management. I mean, at the moment, solar photovoltaics and wind are just so cheap that maybe you just build far more of them than you usually need. This might mean that even on a cloudy day with low wind speed, you'll normally still have enough power. It does mean you have far too much power if it's sunny or windy. And then you've got basically free energy to do something with, perhaps use it to generate hydrogen, which we'll talk about later. A popular idea for many opponents of renewable energy is firming with fossil fuels or nuclear. The idea is that we need those coal-fired power plants or these nuclear power plants to supply power when the wind is not blowing and the sun isn't shining. The trouble is that actually this is not a very good idea for coal plants or nuclear plants. The trouble is that any firming plants are only needed occasionally. You've seen from the graphs that most of the time solar and wind provides plenty of energy. It's only occasionally, especially if you overbuild, it might only be that you need power one day in 10 for a few hours. And coal and nuclear plants are really not good at sitting idle for most of the time and then just turning on for a few hours when they're needed. They tend to work best with a high capacity factor where they're running continually. So that's great if they supply all the energy all the time, which has historically been what's happened, but they're not very good for supplementing wind and solar because you need something that can be turned on and off quickly. Nuclear plants are particularly bad because of the way they're built, but they're expensive to build. If you've spent billions of dollars building a nuclear plant or a coal-fired power plant and all the coal mines and railways to supply them and everything, you're never going to pay that off if you're only selling electricity for a few hours every week. You need to run all the time to pay off the enormous construction costs. So companies that build these things are not keen on this, not keen at all. It's really hard for the politicians to try and persuade them they need to build these things. A better idea is natural gas. Natural gas plants can be turned on and off quickly and they're relatively cheap to build, capital costs are much lower. So natural gas firming is what many people think we're going to need for at least a few years until we come up with some other technique. Most of the time you won't need it. Most of the time you've got plenty of wind and solar, especially if you overbuild and have transmission lines and different regions to average out the weather. But there might still be the occasional period when just it's calm everywhere, it's cloudy everywhere, or the middle of the night. And for those emergency situations, which might only be once or twice a year, you're going to need natural gas. This is highly controversial. Some people think that leaving the window at all open to fossil fuels is going to cause a disaster because people will just get used to using natural gas and not bother replacing it. But it is an option.